Okay, going straight on. Here's the state diagram for our machine, our non-deterministic PDA that behaves like a grammar. Right? So here are 3 states. Here's the label of the transition that pushes the dollar and the start variable. This S here is the start variable for your grammar. Okay, pushes it onto the stack. And then you move into a second state called Q loop. And what's going on here? So if you make this transition back to itself if this or this. So it's non-deterministic, right? Because we have two outputs. So you're making copies. Let's see. So what's going on here? You're ignoring what's at the input string. You're looking at the top of the stack and you see a variable. So you push onto the stack. Well, you pop that variable, pop it, because this is non-epsilon. So when it's non-epsilon, whatever's here, you pop. So long as what's at the top of the stack is equal to what this is in the rule. Alright, so you pop this A, and you look in your big R, the set of rules for your grammar. You look for a rule A arrow W, this string W. So you're going to substitute for this variable A, you're going to rewrite it, if you like, with this string W. Okay, so here you put that W, this right hand side here, you put that onto the stack, push it, put it onto the stack. Okay, and you just you keep doing that. Now if you can't, well, it dies. Now another possibility is if here what's at the top of the stack is not a variable, so it's a little letter, so in other words it's a terminal. So if you now have a terminal symbol at the top of your stack, check that symbol is the same as the symbol you're currently reading on the input string. Okay, and if it is, do nothing with the stack. Don't push anything. But this is not epsilon, so it'll be popped. Okay, so you'll pop that symbol. But that symbol there, that's a symbol generated by your grammar, and this symbol here is a symbol in the input stream. So this symbol here is part of the stream going into the PDA, and that symbol is a terminal in your grammar. But if they're the same, right, and if they're always the same, all the terminals here equal the symbols in your input stream, well, that means the PDA that's acting like a grammar is agreeing, being the same as the input stream. Right? So hence the equivalence between the PDA and the grammar. The PDA is acting as a grammar because it's agreeing, it's describing the same string. Okay, so this is the critical part, and this part here is the PDA acting as a as a grammar, and this part is checking that the two results, the string being generated by the grammar is the same string that's being accepted by the PDA. Right? So that's sort of critical. All right. So assume it goes through. Now let's say in the second position, after the comma, you get $1. So you don't care what's being read in the input string. You look at what's at the top of the stack, and you see that it's $1. Well, that means your stack's empty. That all this matching has been okay completely, and therefore you know that the PDA has accepted the string by behaving as a grammar, right? And hence you have generated a PDA that's equivalent to a grammar because it has been behaving as a grammar. Right? Okay, so then when you detect the $1 at the top of the stack, that means you've been successful at accepting the string, so you want the PDA to go to an accept state. Okay, so your state changes to this. You don't push any. Oh, you pop that $1. So the stack is now empty, completely empty, and you don't push anything on the stack of the epsilon. Okay, so you're just left now with totally empty stack, and you're in the accept state, and that's the end of the input string. And since it's an automaton, it terminates in an accept state, and therefore that string has been accepted. It's been that input string has been accepted by the automaton. All right, let's do an example now. So example 2.25. So use all this analysis we just finished the lemma, like the half of it. The forward direction, the P arrow Q direction, which is equivalent to the only if P, only if Q. Right? So let's do, using this lemma, let's construct a PDA, a non-deterministic PDA, that corresponds to a grammar. And here are the rules, the rewrite rules of the grammar. Now, this is sort of shorthand, but from the rules you can write out the full specification of the grammar. Like it's obvious that's the start state, the set of variables would be st, that's it, and the terminals are a, b, okay, and you augment with the epsilon. Now I guess in this case the stack alphabet would be the same. Little a, little b, and epsilon. Alright, okay. So as usual, the first thing you will do will be to initialize the stack, push $1 onto it, and then push the start variable from your grammar. Okay. Now these little circles, they represent like auxiliary or extra supplementary states. Okay. Now you're pushing $S to get to this state. We did that earlier, so that's nothing new. All right. Now you've got these rules. How many do you have? You've got four rules here. Now, so we're here and we're in state S. Okay. So S is on the top of the stack, and so we want to rewrite S. We want to pop S and replace it on the stack by ATB. Now that's a whole string, so we'll need two intermediate supplementary states. So we get ATB. So now we do it in reverse, remember? So we'll push first, B, T, A, B, T, A. Okay? So push, push, push. So that, and then take us back to Q loop. So that S arrow ATB. Now S arrow B, that's this one here. Yeah. Well, actually, you've got many loops here. So this one corresponds to SB. All right. Now, if you've got a T, if the top of the stack is a T, we want to rewrite it as TA. So we'll push AT. So that's that loop, back to Q loop, and T epsilon, that's this one here. Okay, so that's that one, and we also need to check. Now there are there's a little a and little b as terminals in your grammar, so we want something corresponding to this. So here they are from in state Q loop, looping back. So you'll have A comma A is arrow epsilon and B comma B arrow epsilon. That corresponds to this, right? And here will be the same. So there it is. Just oops. Is that the text? Did I forget to do that? Just a minute. Or did the text forget to do it? Let me just check.